So I'm just going to make a container. For the most part, I keep my kids in a 3x3 stock area. It gives us the availability of having a decent-sized container that they can take home, but it also doesn't waste a whole lot of material for me. So they'll make the 3x3, and the stock that I buy is the 2-inch stock. So when you do your extrusion, same thing, have the kids go ahead and extrude that into the negative so that the CPL, PRZ, WCS, whatever your software wants to call it, will be down there in your bottom corner. And if I do something that you don't see, just let us know and I'll either go back. If I do something that you don't understand, let me know and we'll fix that too. I know in the real world, a good majority of them, they're going to model this perfectly the way they want it to be, and then they're going to throw a piece of stock in the mill that's too big. They're going to mill it out of there. I have my students design it with extra stock in mind. I tell them they're going to get a 3x3, but they might not. I'm going to run over the table saw and I'm going to rough cut this. They might end up getting 2 7/8. They might end up getting 3 1/4. Just kind of depends on how I rough stock it. So I'm going to have them actually give themselves a little bit of a safety boundary. As they come in to design their first part, first thing I have them do is bring in the entire outside 1/8 of an inch. So if they bring in that offset 1/8 of an inch, then that gives me a lot of wiggle room. Gives me a lot of wiggle room all the way around to not be close. And I show them why I'm doing that. I teach them why I'm doing that. And then what I'll have them do is go ahead and cut that safety boundary. And I give them 1 inch for their base. And what you're going to see is the way Chris and I have kind of done a strategy for this, we're going to carve the base out of one side of the material. We're going to carve the lid out of the other side of the material. So we're actually going to get both pieces out of this 2-inch block. Actually, I'm going to shrink that to 0.75. Okay, so now they can see visually on their screen what they can play with. So that is going to be the stock. This is what I'm going to give them. Everything's going to be set up the way we want, and now they can go ahead and play whatever shapes, whatever size, whether they want it to be a hexagon, octagon. I avoid cylindrical things just because they're kind of hard to hold on to later. Even if I create a fixture to hold on to something cylindrical, it kind of causes me some headaches. So if they want to come in and draw, I'll draw a polygon here. I'll make it 6-sided. That's fine. We'll do it this way. So I've got a kid here, and she has decided that they're going to go ahead and create a polygon-shaped, 6-sided shape, and that's going to be their container. Okay, so now they can go ahead and cut the shape of the container. Now, I tried to have my kids keep things as parametric as possible. So instead of typing this 0.75 in, I have them use this to next or twos or things like that so that later on they can make some changes. So they now have their container. They've decided that this is what it's going to look like. Lip-wise and the pocket-wise, for the most part, every single one of mine do the same thing. And we actually sit down and each one of them kind of get the dimensions with me. So I take that sheet that's in the curriculum, and each one of them types them out and writes them all down right off of that sheet. So I'm going to use 1/8 of an inch lip, and I'm going to use 1/8 of an inch raised boss that's going to be inside there. I like to cut down 1/4 of an inch. That's going to be my outside of the lip, and then I'll share that so I can cut my pocket. Now, you can make this as complicated as you want. I try to keep as much math in the class as I can. They know right now that my entire thing was 0.75. That's going to take me down to this bottom lip, and then I have them subtract 1/4 of an inch to give them the 4. I make them leave this math. Nice part about leaving this math is that at any point in time, if I come back into that box, I can see where the formula came from. And if I want them all of a sudden to leave an 1/8 inch floor, if I want them to leave a 3/8 inch floor, they can come back in and change those things pretty quickly. If I just have them go ahead and type in a half an inch, they may not remember where that half an inch came from. So all in all, that ends up being, for the most part, my entire design already. So I'm going to turn on my edges. Now, the part you want to warn the students about is, in reality, the hardest part and the reason we like the container is it's going to start teaching them about tolerances and start teaching them about what the milling bits can do inside and what milling bits can't do outside and those types of things. So right now, if I bring my mill around here, it can perfectly mill that nice sharp corner. It can perfectly mill this nice sharp corner. The problem is going to be when the lid comes over the top of it, I can't do nice sharp inside corners. So that's really where the students need to start becoming better designers. In IED, they just kind of design things without the thought of, can I actually machine these? Can I not machine these? How is this going to work? And they have to realize that if I don't put some kind of radius in my design now, when I design up my lid, the two are never going to fit together. And I've got a couple of containers that don't fit together on purpose just to show them what's typically going to happen here. And the really nice part is in EdgeCAM, they're going to see in EdgeCAM what it was supposed to do and what it did end up doing. So I'm going to go ahead before I start my other side, and I'm going to start putting some fillets on here. The big part they really have to think about is the fillet size here is just as important as anything else. I'm not filling it for this piece. This piece it could do just fine like it is. I'm really filling it for the lid. And if I don't use a radius here that's at least whatever my diameter of the bit is going to be, it's still not going to do it. So I'm just going to pull it out of the air, and I'm going to say I'm going to do this with a 3/8 inch end mill. If I'm going to do it with a 3/8 inch end mill, and 3/16 is the smallest that I could put onto that radius. So you take whatever bit you've got, you divide that in half, and that's going to be the fillet radius that you're going to want to try to use around each one of those corners. And hopefully I'll show you here in a second why that's important if you're not getting that quite yet. So I'm going to go around all of these outside edges. I'm going to go ahead and put that fillet on. And again, I'm using the smallest that I could use successfully with a 3/8 inch bit. Now, I'm not worried about the inside. I know the tool can't actually come in and make this inside. It doesn't matter. I'm not designing this around something specific. If there was something that had to go in there, then I would worry about that, and I would go ahead and fillet those insides as well. Okay, so all in all, I've already, in a short amount of time, I've got my entire base, and that's going to make my lid. I'll do a sketch on the bottom, and I will project geometry from the top. So I'll come over here and I'll project that, and that has now already assigned what the shape of my part's going to be. Did I just project that? I think I just projected that.
Sketch
I
first.
think I did.
I think sketch it first. Put a sketch on there first. See what happens.
Okay. I don't know why I didn't do it the first time. So now I can go ahead and extrude this. I'm going to make my lid. Now, this section that I have in the middle here, that's going to be your important part. You want the students to leave that nice and thick. That's going to be your boss that's actually going to be held by the vise. That's what's allowing me to make these really cool shapes and make the profiles, whatever it is that I want. And you can kind of keep playing around with these, but I will warn you that really 5/8 of an inch is the smallest I've ever really wanted to try to hold on to with that rim shape. If it was aluminum or steel or something like that, I might get away with kind of a smaller boss. But I want to have a nice, big, thick thing to try to hold on to here, and I'm going to do it on purpose to be able to show you some changes here in just a moment. So I've got that first one. I'll do a new sketch here. I'll project geometry again. And everything is going to come off of my hard work from doing the other one. The really nice part about doing it this way is they're going to match. They're the exact same profiles. The problem the students need to know here is my mill will hold a really nice tight tolerance with those IntelliTech mills. If I mill both of these just as they are right now with no tolerance in between them, it's going to be too snug and I'm not going to be able to get them to go together. So I am going to offset this about 3/1000ths of an inch. 3/1000ths of an inch doesn't sound like a lot. It's a little less than a sheet of paper, but that's on both sides. So I am going to give myself just a little bit of slop. And now I can go ahead and cut. The part the kids have got to remember, if I just pick that big pocket right now, I have not picked my tolerance. So they need to come in, they need to zoom in, and they need to make sure that they're grabbing that tolerance there that I have added. And they'll cut that. Okay? Now I want to show you a little trick that I showed my students. I don't like zooming in on that, and I know my students half the time forget that, and they make the tolerance, they just don't use the tolerance. So if I come back into this sketch, and I zoom in on one of my lines, that yellow line is my projected geometry. If I make one piece of it, any of it, a construction line, as far as Inventor is concerned, then it's now broken and it can't see it anymore. If I now go to extrude, it will grab exactly the pocket that I want, and I won't accidentally miss my tolerance. So I don't delete it. If I delete it, that messes up my offset. All I've got to do is turn it into a construction line, one small piece of it, and as far as it's concerned, it's no longer a closed loop. And now I can cut this to 0.5 minus the 0.25 if that's what I want my inside to be. And I can say OK to that. Now, hopefully you can understand why a minute ago I put that radius on there so that my tool could actually come in here and make this. If I didn't put the radius on my base, then the radius would not be in the lid and the two would not go together. I would have nice sharp corners on the base, and I would have round corners on this just because of the capability of my milling machine. Now, since I've got everything hopefully set up right, if I think that this is too much, then I can start coming in and start playing around with the design. If I want that now to be an inch, I can say that's an inch. I can now come back into the one that made the pocket. Oops, not that one. I can see that was 3/4 plus 1/4. I can now change that to an inch minus the 1/4. It gives me the same thing. If you really want to go have fun with the kids and they're very experienced in Inventor, you can have them start setting up user parameters. So they can come down here and they can actually start making some of their own numbers, and you can call it base, and you can call it floor thickness, and you could do all kinds of really cool things. So it's all about your experience of Inventor and your kid's experience of Inventor. And that right there is actually, that should be my 1/2 inch, and that's what I used this year. So all in all, that's my container. I can mill it, flip it over, I can mill it again, I can take it over to the bandsaw and I can split these apart. I then can do a quick facing operation to get rid of that extra, or I can just sand it off. If you want to start doing some fancy operations with the kids to do the lid, to do some really cool contoured surface on the top, you can do those kinds of things as well. Okay. So any questions kind of about just getting this part here?
Just to add something too, Jim, when I do this in my classroom, I make them do a drawing for me, and they have to do the drawing such that they show me a, what do you call it, section view of that, so that they can prove to me, before I even think of doing it on the milling machine, they need to prove to me with the drawing that that tolerance is there between the lip and the lid. And on my two machines, it's 0.002. If I put 0.002 of an inch in there, it'll make the parts perfectly on the two machines. So that's part of the documentation for the project, is to actually make a drawing for me that has the section view on it.
Oops, now let me see if I can find, I'm just going to pick one of my students. So this is what I have my students turn into me. So they'll do the section view of it, and this basically mimics exactly the page that was straight from the curriculum. So then I had the students actually put all the dimensions back on there and prove to me that they got the dimensions that we were supposed to do. They zoom in, they show me that they got the 3,000ths of an inch, and then when they do their surface operation, they do the same thing. So I get one of these from each one of my students before I entertain the idea of what are we going to do. Chris and I both, for the past couple of years, have decided that it works best for us that we mass produce them. So what I actually do is I take this page, right here and I print them, and then I show them to all the students, and they vote on the one that they think is the best design. And then that's the one that we actually machine. That's the one I go through with a fine-tooth comb, and I make sure that it works exactly the way it's supposed to. The one we did this year is, let's see, it's Devon's. So this is the one the students decided to do this year. So this is the main shape of the box that we're making this year. And then it will have a surface on it that looks something like... So that's kind of what the surface operation will look like. So that will be the box that each one of the students gets to take away this year.
Very nice.
Yeah, documentation, like Chris said, is, one, it's vital for them to kind of get that buy-in from IED that we need technical documents, but two, it makes it so much easier for me to grade if I can see if things were correct or not correct. It shouldn't be that hard for me to grab one that wasn't correct. If I take a look, actually these dimensions are all fairly right. Like I said, I try to avoid some of the round things because I have a hard time holding on to some of them. But, so, again, any questions about some of the dimensions we use? Again, the reason I have that 1/8 inch offset, it's really for me and it's for my raw material. There's a lot of people that when they take it into EdgeCAM, they'll actually add material into there. I don't know that there is really a right or wrong way to do it. I try to design more around the shape that I want to be able to do it rather than anticipate that somebody's going to either get a perfectly 3-inch part or they're going to add extra material on their side. I just kind of design it the way I know that it's going to best be machined. But I'm sure there's hundreds of different strategies out there, some rational. Chris, anything else you want to add to that?
One of the things I do in my classroom, since I only have this year I only had one milling machine running, so one of the parameters that we do is that we have to be able to machine it in X amount of time. And this year a total container had to be able to be machined in less than 15 minutes. So that was one of the parameters. So when the kids were designing, our boxes came out a little simpler than Jim's this year, only because we didn't do the complex surface because we didn't have the time to machine it. So whatever works in your classroom, and while the kids all design a container, and they all machine their own container in EdgeCAM, so they all get a grade on what their material, what they're doing, but you really only make one on your milling machine, and you mass produce in it, and it saves so much time. And also with the tooling and the fixtures and the jigs, it's impossible to, if you had 22 kids in a class, to provide a fixture to fixture, 25 different containers, it would take you all year just to manufacture containers. So we found that it works a little better to do one. If you have multiple machines in your room, that'd be awesome. That'd be a great way to do it. But anybody have any questions on the Inventor stuff so far?
Hey guys, where exactly did you cut that apart? The two pieces.
It's not been cut apart yet, and this is actually what you're going to see in the real world. For what Chris and I do, we're going to mill it just like you see it here. I'm going to mill this part. When I'm done, I'm going to take it out of the mill. I'm going to flip it over. I'm going to put it right back in. I'm going to mill this part. Then I'm going to take it over to my bandsaw, and I'm going to split it right down the middle of the boss. And I do that. I don't let my kids do it just because I've not taught them how to use the bandsaw. Then I can put it back into the mill, and I can run a quick facing operation to get rid of the chunk, or I can take it over to a belt sander and I can lightly belt sand the rest of it off. I only have a ½ an inch here, so I like to chunk some of it off. Go to the bandsaw, you can kind of cut it a little bit close. Even if you cut it close to the floor, I have added a ½ inch worth of material in there, so if I get into it a little bit, I have a ½ inch. It's not really going to change things that much. Does that answer your question?
Okay, I see. So you just split it down the middle of that the big square there, and then you go back and fine machine it later.
Yes.
Mill it off later. Yeah.
Yep. And I will show you here in a minute how I do my surface operations, but I wanted to at least give you the opportunity to see how quick. If your kids can do those tutorials that I gave you the other day, then this thing really goes fast. My kids, the last several years, I have not done those tutorials. I've just pretty much showed them a whole bunch of stuff and given them the flange, and then here's the container, and I've just not had great success. This year I spent so much more time in EdgeCAM. They blew through the flange. They had more fun designing the container, and they blew through the container in EdgeCAM. I just think they had a better understanding of it. So, again, I'm going to come over here. I'm going to run the roughing operation. They have done similar things to this. They didn't even have to ask me questions. All they really need to know is the right tooling. And we decided we're going to use a 3/8. They're going to run that roughing operation. They're going to come over to here, and they're going to run this boss or this boss, depending on which one you want to run first, with a profile. So I'm going to use my current tool. That's going to be fine. That's going to run that first operation, and then they're going to run this one. The problem with this one is the one where we have to raise it because it's starting too low, but they already understand that. So we come in here, we're going to use the current tool. They're going to raise their level up a positive ½ inch, which means they're going to raise their clearance. And done. I have my entire container. I have the base of the container, not the entire container. So as soon as I simulate this, I run it. I like to run the roughing operation first just because the roughing operation is my heavy operation. That's where it's really going to be trying to take it out of the mill. So I try to do that when I still have quite a bit of stock around the outside. Now, these little corners here, they're never going to stay. I can just take this over to the bandsaw, and I can knock those little 4 corners off. I can snap them off. If you really wanted to, I could do an offset with that like we did earlier. I can do an offset and try to take some of that material away, but it's going to be trash anyways, so there's no point in me running cycle time to try to remove that extra material. So I can come in right now, I can run my cycle time. It tells me that's going to take about 7 minutes to run that base with those. Because it's ring shape, honestly, I can start pushing the envelope a little bit, where I'm only cutting these at 3/16 of an inch. I can start pushing my mill a little bit, but that's also why my mill has lasted a really long time, is because I run things a little bit slower. There's a lot of people that they'll go all the way down 3/4 of an inch, and they'll cut all that in one shot. One, that's not real world, and two, it saves my tools, it saves my machines, but it adds cycle time. It adds, I got 30 containers to try to machine all in one class, but that's why I will be machining containers while my kids are working on RoboCell. I use that as my filler. So my kids are doing the pick and place. I take 2 and I throw them out in the lab, and they start running their containers. When they're done, 2 more kids go out there. By that time, we're on the stack, and those kids. So they just kind of round robin as they go out there. My kids, if they don't have something to do, then that's when they start throwing things. So roughing operation, profiling, that's done. I save that as my base. I'm running in homework mode right now. I click on my NC, I give the teacher the code, and that's done. I do make them give me several photos. Oops, let's run it. And comparison-wise, you'll see that the inside didn't quite do right. It didn't do it the way it was supposed to. That's fine. I really don't care about the inside. So let's see. I'll pick one of the students. I'll show you the paperwork that I have them turn into me. I'm big on paperwork, but they turn it all in electronic, so as long as I'm not printing it. Oh, she's got them as Google Docs, so I'll open one up. So she should give me one of these documents for every single piece, and this will have a ton of pictures. It'll have the inventor model, it'll show me the tool paths, it shows me her sequence, it shows me the verify, it shows me the comparison, and then it shows me the cycle time. So she's using a half-inch tool, which is what we use this year, so she's able to get her cycle time down to about 3 minutes for that entire part. That's pretty decent. But, yeah, paperwork. My kids grab these little screen captures of every single thing. This shows me the order that she did. It shows me what tool she's used. It shows me all of their operations. I get to see the verify. I get to see her comparison to see if it was done right. And that's really what I'm looking for. So once I have that saved, I can then go ahead and open up the exact same piece again. This time I'll flip it over. This is why they have to know how to set up a CPL, because they're going to do it. I'm going to go ahead and create my part. I'm going to go ahead and change my CPL to my new top. Once they have that done, oops, what the hell just happened? Try that again. So origin, X positive, Y positive, origin, there we go. Feature finder, features found. This one should be even easier than the other one. I come in, I do my pockets, roughing operation, no boundaries. And then I go ahead and do the blast with the same tool. Oops, not a roughing. That one's done. So hopefully if they did not do that filleting like I showed them to, when they go to the comparison, they'll see these bright blue parts in here. Now the reason I have these blue parts is because there's an offset in my profiles. Remember, it remembers your settings. Oops. So, and they grab me all their screen captures, and they've got all that. So the actual EdgeCAM part of it, you know, once you get to be friends with EdgeCAM, take it out to dinner every once in a while, it can be your friend. You can get through these things pretty quickly. But you do have to be nice to it. So, any questions about those two pieces through EdgeCAM?
And I find, too, that if a kid can do the flange or all the operations in the flange, their container really ends up being a piece of cake for them. They really start to get it. In designing with the different tools and the different radii, that's what they start to think about. They start to think about the design now.
But I can tell you, if my kids did this with a half-inch tool, it won't come out right. So earlier when I said that you've got to make sure that that radius matches the tool that you're going to use, right now I did not put a radius on there that was going to be big enough. So because it's not big enough, so I come in and I run it. Now that radius in there is not what was designed. Those two pieces will not go together. The base is designed to be done with a 3/8" tool. I just used a half-inch tool. This radius inside here is too big. They'll not fit together. They'll be close, but they won't fit together.
And this is where the point, too, the kids will figure out, okay, if I want mine to come in under time, I have to go back into Inventor and redesign my other side so that's rather than a 3/8, I can make it a 1/4 inch, and all of a sudden I can now machine my whole container with a half-inch tool and cut the time considerably.
But because we did this all as one chunk, because I changed the fillets on the top one, it just changed the fillets on the bottom one. So everything now matches.
And that's the nice thing about parametrics. Now when you open up EdgeCAM too, it'll ask you,
So if I go back, it'll tell me that something has now updated. Now I will warn you, you got to kind of understand, even though I said yes to it, I don't know about that, but you have to go back into your sequence. You have to open the first one and say OK to it and OK to it. It will then rebuild the paths all the way down. If you don't actually go through and do anything, it won't change the paths. It understands things change. It gets that part, but it doesn't auto-update itself. And there's no little lightning bolt up here like there is an Inventor that says, oh, there's changes. Do you want to make those changes? You have to open up your very first sequence, say OK to it and OK to it. You don't have to do anything, but it will reevaluate the part and it will reset up your tool paths. We found that out a while ago when we went ahead and machined it and things were still not right. They didn't match what we wanted them to be. We didn't realize it didn't actually make the updates the way we wanted it to. Okay? All right, well, if there's no questions there, what I will do is go ahead and show you how to do that surface operation. Again, I'm a fan of Inventor, but I'm also a huge fan of the parametric parts. So this next part, even those of you that use Inventor, this may be something that you don't use on a regular basis or something that you've never used before. I'm going to create a new standard IPT. What I need is I need this piece, and this piece is buried inside there right now. So like Glenn said, I am going to split it. I'm going to do a facing operation, but I need to get to my part. So I'm going to borrow it. What I'm going to do is I'm going to manage. I'm going to go to manage, and I'm going to come here to derive. This is probably going to be a new thing for a lot of you. This is a tool that I use a ton. It allows me to borrow pieces, and I can cut on them, I can do whatever I want to them, but I don't damage the original. The original still is the original. So when I derive, it's going to say what do I want to borrow. And what I want to borrow is I want to borrow my container. And when I do that, there's all kinds of cool things we're not going to get into. All I'm going to do is just say OK. And I now have borrowed the other piece. I can now cut it up. I can do whatever I want to it. And that's exactly what I'm going to do. I'm going to relocate my boss over to the other side. That's just for indexing. That's for the auto stock. And then I'm going to cut everything else away. That way I can get at my actual part. Oops. So I will make all of this go away. So I'm going to cut all, and I now have my lid. And I have the base. If I make any changes to this one, edits, sizes, whatever, this one will change too. So if I come into here and all of a sudden this was not supposed to be a 3x3, my teacher has changed things, it's going to be a 4x3. As soon as that one's finished, this one will be the same thing. It will update itself to match my other one. Okay, so that's supposed to be the power of the parametrics. Now I can have my kids come in here, and even if we run out of time every year to actually machine these fancy surfaces, I still have the kids do it so that they can prove to me in EdgeCAM they can actually make surfaces. So I'm just going to throw a real quick one on here just to give me something I can take into EdgeCAM. So, oops, I got to get rid of that. So all I'm going to do is just a simple loft. That's what a lot of my kids will go ahead and do. It's just a simple shape that's going to be on the top that they can do kind of a cool surface operation to. So there we go. That's going to be my surface operation. I can now go in Inventor and I can do that. And same thing, because they've done the tutorials now, they can blow through this pretty quick.
Another thing, too, some of the kids at first say, well, you know, I don't want Jimmy's container. I really want to make mine. Well, we don't have the time, but what you could do also is you could put a small pocket in the top of that, and if you have a laser engraver at your disposal or somewhere within your district, each kid could then engrave something, whatever they want, whether they're a Buffalo Bills fan or a Steelers fan, they can engrave whatever they want on the top of that lid, or they can actually cut one out of acrylic and force fit it in, and they come out looking really nice.
Now, the reason I move my boss over to the other side is for this reason right here, this auto stock. When I go ahead and say auto stock, it's going to refine my part back into the middle of that. It just makes it easier for me when I go back into the mill and I put it back in to be able to make those parts. And same thing, they have to know how to reset up that CPL because it's now in some wonky position. So once I have that set up, I don't even need Feature Finder. I'm not going to use Feature Finder. If I want to go ahead and establish a boundary to stay out of, I can do that, which I will do. Oh, come on. Not smaller, bigger. So I will tell you, for some reason, EdgeCAM has gotten a little bit hokey trying to find some of these boundaries. Sometimes, like right here, for some reason he can't find it. I don't know why. And sometimes he can find it here. Sometimes the kids will have to zoom in. Sometimes they'll have to rotate it. But that's an area that I want it to stay out of. And then sometimes it depends on which surface operation the kids use. If they use Z-level finishing, they won't need this. If they do constant cusp, I think they will. One way or another, they'll need this, either this top boundary or this bottom boundary. Otherwise, it'll kind of go all over the place. And for whatever reason, today he doesn't want to find it, so we just won't pick it up. So I can come in here now and I can do a quick surface operation. I'm going to do Z-level finishing. The hard part the kids don't understand, there is no material here. It doesn't exist. There's nothing there. But auto stock is just found it as a rectangle. You can in EdgeCAM, you can make stock the shape of the part, but that's just a nightmare. So I'm just going to say pick the whole thing, enter, and we're going to kick this as my boundary. You have to have, if I want to stay out of, I have to have it stay inside of. That's why I typically like to have the one that's the shape of the part. I just wasn't going to waste time trying to find it. And depth-wise, that's going to be fine. I really only need to have about 1/4 of an inch. Roughing, there's not really that much there, so I'll say no roughing. And then finishing, I'm going to do the Z-level finishing. I'll pick my 3/8 ball, and I'm going to do a cut increment of like 20 thousandths. And it'll do that part for me. Same thing, when they come into the simulate, the kids get all confused. They think they're supposed to do a profiling operation, all these extra things. There's nothing there. There really is no material here. All I've done is a nice surface operation. Now, I will tell you that's where a good majority of them just end. This is where I kind of make things a little bit more complicated with my kids. Because like you say, Glenn, I have material on the top of there, oops, that I'm trying to get rid of. I go ahead and throw a surface operation in there. A facing operation. So when my kids go ahead and auto-stock this, I have them go ahead and add an extra 1/4 of an inch in the Z. That's now added the material that's there from the bandsaw. I don't like, I've done it in the past where I have them manually face it off, but then keep resetting the origin. It's just been nice the past couple of years once we started doing this. They just do a quick facing operation. I just made that upside down. So reset the CPL. Here, 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 here. There we go. I'll still go ahead and define that boundary. So when they come in here, I have them do a facing operation that's 1/4 of an inch to get rid of that stuff. So they'll come in, they'll face it, they'll select those boundaries. Makes it very easy for me. All of this they've already learned how to set up. If they want to do a tool change, they can pick their 3/4 inch end mill. We're going to cut something like 1/16 of an inch, and they're going to go into the part to take off that chunk that I just added. Now they can do their surface operation just as they've done before.